Hey everyone, and welcome. Today, we are putting on our architect hats. But we're not designing buildings. Nope, we're talking about something way more complex, a machine learning system on AWS. So let's just dive right in and start with the most fundamental question of all.
Seriously, how do you build a machine that can actually see the future? Well, imagine you want to predict which of your customers are about to cancel their subscription. It's a classic problem called churn prediction, and it's the perfect example of what we're architecting here. We're building a system that looks at all the data from today to make a really educated guess about what's going to happen tomorrow. And just like building a skyscraper, you don't just start laying bricks. It all starts with a blueprint, a detailed architectural plan that lays out every single component, every connection, every little piece. And that's exactly what we're going to walk through, the complete architectural blueprint for the entire machine learning lifecycle, step by step.
Okay, first things first. Every great structure needs a rock-solid foundation. And in the world of machine learning, that foundation is always your data. I can't stress this enough. If you get this part wrong, everything else you build on top of it, well, it's probably going to come crumbling down.
So what does a strong data foundation actually look like on AWS? It's basically a three-step pipeline. First, you ingest all your raw data into a central data lake, and that's usually Amazon S3. Think of it as a massive, super secure storage bucket in the cloud. Second, you use a service like AWS Glue to scan that data and automatically create a searchable catalog, so you actually know what you've got. And finally, you transform it. You clean it, you format it, and you get it ready for a machine learning model to actually understand.
But here's where the architecture gets really interesting. It's not just about the tech, it's about the teams. This handoff point is absolutely critical. You see, the data engineering team, they're the ones building that powerful pipeline. But it's the ML team that has to define exactly what that final transformed data needs to look like. A good architect designs a clean, automated interface right here to make sure nothing gets lost in translation.
All right, with our foundation firmly in place, it's time to head down to the engine room. This is where the magic happens. This is where the core intelligence of our machine is forged. We take all that beautifully prepared data and use it to train a model that can learn patterns and start making the predictions we're looking for.
Now, as the architect, you've got a major choice to make right here. Do you go with a managed, kind of prefabricated engine like AWS SageMaker that handles all the heavy lifting for you? Or do you build a completely custom engine from scratch on virtual machines, that's Amazon EC2, or maybe using containers on EKS, which gives you maximum control over every single nut and bolt?
So let's talk about this trade-off, because it's so important. If you're a startup and you need to validate a new idea like yesterday, SageMaker Speed is going to be your best friend. It just abstracts away all the infrastructure so you can focus on the model. But if you're a big company with a research team that needs some very specific bleeding-edge library, you're going to want the total control of a custom build. The right choice here isn't just technical. It's about matching the tool to what your team really needs.
Okay, our engine is built, it's powerful, it's tuned, and now it's time for the launch. This phase is all about taking that trained model out of the lab and making it available to the real world so it can finally start doing its job.
But hold on, before any launch, there is always a pre-flight check. This is model evaluation. You have to test your model on data it has never seen before to make sure it's accurate and reliable. I mean, you wouldn't launch a rocket without testing the engine, right? Deploying a model you haven't evaluated is just as risky.
And here we are again, at another key architectural fork in the road. For deployment, you could use SageMaker endpoints, which is a really simple, serverless way to create an API for your model. Or, if you have more complex needs, you can package your model into a container and deploy it on a service like ECS or EKS. That gives you absolute fine-grained control over how it scales and communicates with everything else.
And we have liftoff. Our machine is live, it's running, it's out in the wild, but the architect's job is never really over. Now, we move up to the control tower. From here, we're going to monitor the system's performance, its health, and its accuracy to make sure it keeps running smoothly for the long haul.
So what are we watching for from up in our control tower? Well, we're monitoring performance. How fast is the model responding? We're monitoring reliability. Is the system actually up and running? But most importantly for ML, we are constantly on the lookout for something called model drift. That's when the real world starts to change, and your model's predictions slowly, quietly become less and less accurate. Catching that drift early is the absolute key to long-term success.
So, we have walked through the entire blueprint, from the foundation all the way up to operations. To wrap this all up, I want to give you a practical tool you can use, the architect's final checklist, to help you design your own incredible systems.
So before you write a single line of code, a good architect always stops and asks, is my blueprint truly complete? Let's run through a quick final checklist together to make sure you've covered all your bases.
First up, your data foundation. You need to know, where is all this data actually coming from? Is it a nice clean database or some messy, unstructured source? Next, what's your plan for quality control? Because remember, garbage in always means garbage out. And finally, how are you securing it? This is not an afterthought, it is absolutely fundamental to building a system anyone can trust.
Now for the engine room, model training. What kind of horsepower do you really need here? Are we talking about a standard machine, or do you need a supercomputer in the cloud? And then, how are you going to track your experiments? You need a digital lab notebook to make sure your amazing results are repeatable and not just some happy accident. And of course, that crucial choice, have you deliberately chosen between managed speed or custom control?
And finally, for the launch and for ongoing operations, how will other applications actually use your model's predictions? Is it a simple API call? Then what happens if your app goes viral overnight? Do you have a plan to scale from 10 users to 10 million? And most critically, what is your early warning system for model drift? You need an alarm that's going to go off the second your model starts losing touch with reality.
So there it is, the blueprint, a complete architectural plan for building intelligent, powerful systems on AWS. The tools are there, the plan is in your hands, so the only real question left is, what will you build?